ready to see some chemistry magic? Yeah! So, welcome to our annual Chemistry Magic Show. We're really excited to get started. It's National Chemistry Week this week right now, and the theme for this year is the sweet side of chemistry, candy. Anyone out there like candy? Are you excited to go out trick-or-treating in a week and get more of it? Yeah. So we're going to do a few Halloween-themed tricks because it's so close to Halloween. And after the show, we have hands-on activities for all of the kids up on the third floor of Porter Hall where we have some candy to give you. So head on over there. And once you get over there, you'll be able to make some slime, you'll make snow, and do some other activities where you can get candy prizes. So third floor of Porter Hall, right after the show, you can follow the chalk arrows on the sidewalks. So speaking of sweets, we need to thank for the delicious cookies outside. They were provided by the Office of the Vice President for Academic Affairs. So it looks like we ran out, so hopefully everyone that got cookies wanted one. But if not, there will be candy over on the third floor of Porter Hall. So one thing I'd like to mention before we get started, there's another show in here at 6 p.m. tonight. And so we have to get everything cleaned up really quickly. And you can all help us out by, when you leave, please pick up any trash or anything that you brought in with you so that we can get ready for the next event in the evening. So does that sound like a good plan? Yeah? All right. Okay, so one last thing before we begin. Here at Adams State University, we practice safe chemistry. So what that means is whenever we work with chemicals, we have our chemical safety goggles on. So that's what these are right here. There we go. And I'm going to need all of your help. So sometimes we're really excited to do these magic tricks, and we forget to put our goggles on properly. So I want all of you to help us out. And if you see someone come up that doesn't have their goggles on their eyes, let them know. So let's do a little practice. So let's pretend that I'm coming out to do a trick and I don't have my goggles on. What are you going to do?
Get your goggles on! That's pretty good. Let's see if you can do it louder one more time. Good! Perfect!
So now remember that. You have to help us out. Help everybody remember their goggles. Okay, so let me put mine on. To get started here, I'm going to move this table back a little bit so things don't fly out into the audience. And so our first trick that you saw, the magic writing there, was performed by Lydia Hunt. And what she did there is she sprayed on something that we have is called an acid-base indicator. And so it changes color if you have an acid or a base. And this indicator is clear when it's in neutral or acidic solutions, and it turns pink when it's basic. So window cleaner has something called ammonia in it, and ammonia is a base. And so when she sprayed the ammonia on it, it changed it to its basic color, which was kind of that pink color that you saw. So that's our first little chemistry trick. All right, so now we're going to have Julie Madden come out and do a trick called elephant toothpaste. So while people are setting up, I have some really cheesy chemistry jokes. If you've had chemistry class before, they will probably make more sense than if you haven't. But so if you don't quite get the joke, keep it in mind when you take your science classes in the future. It'll make more sense. So, question: what do you do with a sick chemist? Any ideas? If you can't helium and you can't curium, you might as well bury 'em.
Okay. Okay. So, how many of you guys like elephants? All right. Have you ever wondered how they brush their teeth? All right. Well, I'm going to show you how to make elephant toothpaste. So we're going to go ahead and make it. We need a cleaning agent. So I have some soap here. Get a bunch of that. And then we want something to whiten with. So I got some hydrogen peroxide.
Can everybody see the cart with the table in front? Are we good?
No? Okay, let's see if I can get closer to the on too. Alright. Okay, can you see
Alright,
that
is that
better? Alright. So now we need something gritty to get it really clean. So I'll go ahead and add some of that. Okay.
Oh, I think I see something.
Alright. Think that's enough for an elephant? Okay, so the way that this works is I have the hydrogen peroxide, but I add a catalyst to get the reaction to go faster. So now we have all of this foam for the
So what
elephant.
kind of reaction is it? What happens to hydrogen peroxide?
So the hydrogen peroxide reacts with the Ki, the potassium iodine. Alright, so I'm gonna go and find an elephant.
All right, let's say Julie. All right, now we're going to have an experiment that's done in the dark by Sean Brazilian.
That's a little bit dark out there, isn't it? You can see okay. That's good. We bring the lights down a little bit further. Thank you. Oh, now it's good and dark. So, I would like to see something. What about you? Do you want to see something? Are you dark in here? Let's see what happens when I do this. That's better, isn't it? There we go. Alright, lights can come back up now, thank you. So that is a reaction called, in this speaker we have something called luminol. In this one we have hydrogen peroxide. Now, when the hydrogen peroxide reacts with the luminol in this beaker here, there's going to be some energy released. And in some reactions, such as this one here and in glow sticks, that will actually release light that's visible to us. And that's what we see here, is this nice blue light. There are others that can do different colors as well. Thank you guys. It's been a pleasure.
All right, thank you, Sean. So, what do you call a clown who's in jail? Any ideas? A silicon. So silicon is an element. All right, so we saw some things glow in the dark. Now we're going to see some pretty rainbow colors. Yeah. So Christian Manager is going to come out and do that. While we're doing that, I'll do another joke here. So, Helium walks into a bar. Sorry, probably most of you have never been in a bar. The bartender says, "We don't serve noble gases in here." Helium doesn't react. You know, the problem with chemistry jokes is you have to have had some chemistry to get them, right? Oh, I'm sorry. I misread. Actually, before we do the rainbow, we are going to have a blue bottle by Nicole Wagner. So do you guys want to make a blueberry drink? Yeah! Alright, so we start with water. And we're going to put it into our flask. Now we're going to sweeten it, so we'll add sugar. Now mix it up a little bit. And now we can add our blueberry drops. And now we can shake it up. And we have our blueberry drink. Ooh, looks refreshing. I bet that would go really well with those cookies that we just ate, huh?
Yes. So, I'm going to give it to someone so you can watch it carefully, and I'll be back.
All right, thank you, Nicole. So now Christian is going to come out and show us a rainbow color. So,
Hey kids. Alright, how many kids like Kool-Aid? Yeah, I got two for you guys. Did you guys know you can turn Kool-Aid into a rainbow? Yeah, it's fun stuff. Just have to add a little bit of this stuff.
Yell a little louder.
With some dry ice. One alone. We got a rainbow. But to finish a rainbow, we have to add a little bit extra. You got a little bit more. And you have a rainbow. Now, it wasn't really Kool-Aid, it was just some water with a strong base called sodium hydroxide. When you add the dry ice, during the reaction it creates a weak acid, and that's what causes the indicator to change color. And what I added at the end was HCl, which just makes it more acidic and turns it red. And that's it.
thank you, Christian. So how's our blueberry drink doing down there? Doing well? Does it still look like it's the same color? No, what happened? Something happened to your drink, Nicole.
What happened? What'd you do to it? There we go.
So the blueberry drops is a methylene blue dye, and it's and it's a reaction that has an oxidation which creates the blue color, as you saw, and it also has a reduction reaction that makes the clearish color. When oxygen is added, it'll oxidize the methylene blue and make it the blue color. The sugar that we added is a reducing agent, and that'll reduce the methylene blue to the yellow color, or clearish. And to get the blue back, all you have to do is add some more oxygen, stir it up a little bit, and then let it redissolve into the solution, and you can have your blue again.
Thank you.
All right, now we're going to welcome Lydia back on the stage, and she is going to do something with pickles, I think. Once we get our rainbow pipes cleaned up. So let's see. A neutron walks into a bar. I don't know all these bar questions for a bunch of kids here, I guess, but. Too many mics around here. So a neutron walks into a bar. He asks the bartender, "How much for a beer?" A drink. "How much for a drink?" The bartender offers him a warm smile and says, "For you, no charge." Okay, here's one that probably everyone will get. Why are chemists perfect for solving problems? Because they have all the solutions.
Hi guys. So did you know that you can make a pickle into a light bulb? Who believes me? All right, those that don't believe me, you're about to be proved wrong. Okay, ready? Yeah. Okay, wait for it. How did I do that? So these metal nails are electrodes. And are pickles salty? They're very salty. So the salt in the pickle helps the electrons move. And when electrons move, you get electricity. And that's how I made my pickle into a light bulb.
Thank you. So, nothing like the smell of roasted pickle. Can you smell that in the front row? Yummy. So, how many of you have drank out of a styrofoam cup before? Do you know what that is? A white cup? Do you think that they're easy to break apart or to get rid of? Yes? Actually, real styrofoam that's made out of plastic material doesn't decompose for hundreds and hundreds of years. So it's something that we're trying to find better ways to make cups out of instead of styrofoam. So now Sean is going to do some experiments with styrofoam.
Alrighty, for my demonstration today, I'm going to need a couple volunteers. I'll take you right there in the front. Oh, yeah, both of you. Now we're going to have a little competition. And we're going to have each of you stand on one side. So you can stand over here and you stand over here. And we're going to see who can fill up their beakers the fastest. Alright, and now in each beaker I have a little bit of liquid that may or may not help you win this competition. Yeah, one styrofoam at a time. Be careful, please.
I thought you were going to dump the whole thing in.
Alright, so on the count of 3, I want you guys to go. 1, 2, 3. Alright, we seem to be having someone in the lead. Alright, it looks like we have a winner over here. Since everybody likes to win, I have a prize here for each of our volunteers. Alright, now, you guys may be wondering why in this beaker all the styrofoam just dissolved. So in this beaker, the special liquid that we have is acetone. And when styrofoam is made, it starts as a liquid that turns to a solid. And when it turns to a solid, a bunch of gas gets trapped into it. And what the acetone helps do is reliquidize that styrofoam and let the gas escape. And that is that. All right, thank you.
All right, that was Sean Detail. Thank you. All right, now Samantha Sargent is going to come out and play around with a little fire. Who likes fire? Yeah, fire's pretty fun. Only with the supervisor, right? Supervisor involved.
Better? So, I don't know about you guys, but some of that blueberry drink was really good, and I think I need to make much more. So, I found a bottle in the back, but not sure how clean it is, so we're going to clean it up. I got some nice cleaning solution. Shake it up. I think it's good. Hold on a second. I think this will help. Oh. Hold on. Shoot it up some more. Being really stubborn right now. I don't know if I can be. What should I do?
So you're going to try another one in the back?
Yeah, let's try that
Should we
one.
try a different one? Let's give it a try. second time's a charm, right? All right, let's cheer her on.
Alright, let's see if this one works. Nope, no liquid.
All right, that worked. All right, thank you, Sam. All right, so that was an example with fire, which is really hot. So now Damien Culver is going to come out with something that is really, really cold. All right, looks like I have a couple chemistry jokes here left. So, a small piece of sodium that lived in a test tube fell in love with a Bunsen burner. You ever seen a Bunsen burner before? It's just a little tube that has a flame coming out the top. Oh, Bunsen, my flame, the sodium pined. I melt whenever I see you. The Bunsen burner replied, it's just a phase you're going through. So when you change phase, you go from a liquid to a solid.
Everybody hear me? How are you guys doing today? This is pretty cool, right? We got liquid nitrogen here. It is at negative 320 degrees Fahrenheit. Right now it's probably, well, 65, 70 degrees Fahrenheit. So that's a huge difference, almost 400 degrees. So what do you think's gonna happen when I stick this balloon in here? It's gonna pop. Let's see what happens. Well, we got some bouncy balls here. You guys, anybody seen a racquetball? Kind of like a tennis ball, just without the fuzzies. Just gotta stick it in there, see what happens later. Alright, to deal with it, I gotta wear my handy gloves because that stuff's cold. Alright. Who doesn't like to see things break? Let's see what happens. Please. Slow. Banana. Got some beautiful flowers here. Smell awesome. Just gonna stick these in here. Why not? Breaking seems fun. Almost as fun as fire. Need a little bit bigger beanie there next time. Let's see what happens. It's shattered. Not very epically. I got some cooler stuff left. A little bit longer than that. This balloon's a little too big, I think. And that was gone. Alright. What do you think's gonna happen to the banana? Shattered. Let's find out. Not bad. This is taking too long. Alright, you guys ready to see a racquetball break? See? It's not bouncing anymore.
It's very cool.
Yeah, very, very, very cool. So what do you guys think would happen if I stuck my fingers in here for a long time? Freeze? No, but I'm warm. Well, let's find out. I got a surrogate hand here. Ew. Gotta do it on the fingers. Lots of chunks and little sausages.
I would not recommend trying this at home, kids.
No, do not try this at home. See the blue. Yeah. Like magic. Look at that. Now watch. Now it's growing again. It's because it's so cold, it makes that air get closer together. And then now, as it warms back up to the room, it gets bigger again. All right, thanks, guys. Enjoy the rest of your day.
It's also really good at cleaning the dust up off the floor. Okay, so we had some really, really cold stuff. So how about we have another explosion? Okay. So we're going to have Christian and Julie come back out with a pumpkin. And they're going to do something with it.
All right. So how many of you guys are going to be... Oh, yeah, go ahead. So how many of you guys are going to carve pumpkins for Halloween? All right. Well, as chemists, we like to carve our pumpkins a little bit differently. We'll show you how we like to do it. So I got some magic powder. All right, I got some liquid. All right.
Ready?
Oh, we might have used it all. All right, we didn't, looks like we didn't get it all the way. Should we do it again? Oh, okay, well, it might be a one-time thing this time. So Christian's going to explain how that worked.
Just a delay carving.
There we go. All right, so the black powder is calcium carbonate, and when you put water on it, it creates acetylene gas. And when you ignite that, boom. That's it.
All right.
So that's our last trick for the day before our grand finale. So give a round of applause to all of our presenters. And then they're going to come out here and get set up. I just want to remind you, please pick up anything that you might have left in the aisles. And that we have hands-on activities for all the kids and Kids at Heart on the third floor of Porter Hall. So that's where we normally have them. So just follow the arrows. It's a couple buildings down across the street. And so for our grand finale, we're going to do the 1812 Overture. I should warn you that this is going to be quite loud, and so to protect your ears, you're going to look like little fishies. You have little fins by your ears. And so, if it looks like something is going to explode, go ahead and cover your ears with these little fins, and it will help protect you. And I know there's a lot of little babies in the crowd, so there are going to be this number of explosions. So, if you think they'll like it, you can stay in.
you.